Okay, due to some technical error, the class was not getting connected. So we'll discuss about. Okay, so due to some good afternoon. So let's start the class. Due to some technical errors, internet was not getting connected here. Okay, uses of epidemiology. The epidemiology, as described by J.N. Morris, has identified seven distinct uses of epidemiology. So most important thing is, as I said earlier, that we will have a brief discussion about the topics. We are not going into the detailed discussion about topic because this is a revision class. So epidemiology is a means of learning or asking questions and getting answers that lead to further questions. So this was the thought of J.N. Morris. This is not a definition of epidemiology, but this is what is the meaning of epidemiology. Now coming to uses of epidemiology, the epidemiology is a branch which studies the trend of the study. If you want to know the trend of the study, it's a trend of any disease or any risk factor of the trend or any risk factor of the disease. If you want to study any trend or pattern of certain disease, it can be done through epidemiology. So it's a trend study. Then community diagnosis. So you can do community diagnosis in, like, community is suffering from any specific kind of disease, like you are still living in pandemic right now. So the community is the world, the entire world, and all the communities in the world are suffering from pandemic of coronavirus. So it is used, epidemiology, one of the use is to do the diagnosis of community. Just like we do diagnosis of an individual person, we in community medicine you do diagnosis of community. Okay, health services and planning and evaluation. Epidemiology is also used to evaluate the health programs at district health programs or national health programs or state level health programs, and evaluate and helps in planning. Like when you evaluate, you put up a report and then you can have a further planning. Okay, so epidemiology is used for health services planning for the country and their population and evaluation. Now, to know the individual risk and chances, epidemiology is also used to know the individual risk and chances. Like we evaluate risk factors for independent diseases, we evaluate risk factors for mortality, we evaluate major risk factors for major diseases. So, individuals' risk and chances. It is also used for syndrome identification. So epidemiology, there are the syndrome means the cluster of risk factors or cluster of diseases or cluster of conditions which make which have a common path and makes the and inter means there is a inter symbiosis. There is a uh, each factor in that syndrome complements the other factor. Like one is present, the other one also gets accelerated. So that is a syndrome. It's a cluster of risk factor to cause specific disease or cluster of diseases or conditions. Now then completing the natural history of the disease. So when a disease is launched, when the disease is discovered or disease comes into picture, like coronavirus here, it's very important to know the natural history of the disease. The natural history of the disease means how how the disease infects the person, what is the incubation period, what is the pathogenesis, what is the when the symptoms are when symptoms surface, how is the progress of the symptoms, how is the progress of the disease till the end of the life. So that is known as natural history of the disease. The epidemiology is also used to know and learn the natural history of the disease without any intervention. Sorry. Searching for cause, searching for cause, risk factor, and establishing causal relationship between risk factor and the disease. Now, trend study, the studying the past history means the studying the past history of the rise and fall of the disease. Now, studying its changing behavior of the disease, making further predictions, and giving early warnings to or feedbacks. Okay, this come under trend study. This is an example of smallpox. I will just exclude this. Now, community diagnosis. When we talk about community diagnosis, it is divided into community anatomy, community physiology, community pathology, community sorry, quantification means okay, quantification, qualitative estimation, community diagnosis. And there is also known as community therapy or community treatment. Okay, it is just like the other subjects like anatomy, physiology, pathology. Here it is social anatomy, social physiology, social pathology of the entire community. Now coming to social anatomy, it deals with race, age, sex, composition, socio-economic status, population risk, and resources available. Social physiology means it deals with positive and negative lifestyle, occupation, health services, awareness and utilization, nutritional policies, and labor of the community. Social pathology deals with morbidity, mortality, disability, alcoholism, smoking, crime and violence, risk prone behaviors. Quantification means by morbidity and ratio and by mortality ratio. Quantification can be done by morbidity ratio and mortality ratio. Coming to community diagnosis, the burden of the disease in the world of in a world of change, epidemiologists have special duty to observe the impact upon the people and the way of life, to diagnose where well-being is increasing and where losing out, to probe for united consequences, to identify trend and to think ahead. Okay, in this, the degree of risk assessed is by relative risk to know the individual risk and chances. So relative risk and attributable risk we calculate here. By cohort studies, relative risk is smokers are at 10 times greater risk of developing lung cancer than non-smokers. Okay. Now, in attributable risk, 90% of the lung cancer among smokers is due to their smoking. Smokers exposed to asbestos are at much higher risk than non-exposed. So these are examples. Again, I'll just skip the examples. In health services planning and evaluation, it is health planning for appropriate, cost-effective, community need based, or judicial mix prevention, promotion, curative and rehabilitative and public health services. The health planning is done in terms of how much it is appropriate, how much national program or any health program is appropriate for the population, how cost effective is the how cost effective is the uh, program, community need, is it addressing to the community need, or judicial mix of preventive, promotion, curative, rehabilitative and public health services, the what kind of qualitative services are being provided, and is it reaching to the mass population or not. Okay. Now, planning for facilities for medical care. So this is health planning for all, for various different reasons. Then planning facilities for medical care, then planning facilities for preventive services, and planning for research. Now coming to evaluation, to know the efficacy of the preventive measures taken, it is done to make choice among various methods depending upon the cost effectiveness of the study, like hepatitis vaccine, weighed against the cost and efficacy. Evaluation of intervention means by randomized control trial, like for example randomized control trial. Evaluation is a beta blockers, that is an example. These are all examples. Yeah, so this was from the uses of epidemiology. Now we will try to see other topic. Let's see. Okay, this I will take it tomorrow. I'll start statistics tomorrow. discuss normal distribution. Yeah, this is another very important topic, which is normal distribution curve. So normal distribution curve. So what are the so when we talk about normal distribution curve, there is a distribution. When we talk about there are biostatisticians assume that the biostatisticians assume that anything in this world is normally distributed. When it is normally distributed, that means if there is a high blood pressure, it is normally distributed into the population. Like the positives and the negatives, there's a mean and then there is a positive and negative. In both the sides, it is normally distributed. So we do any analysis with the assumption. When I'm saying assumption means assumption. We hypothesize that everything is normally distributed. Okay. Now, types of distributions are frequency distribution, normal and Gaussian distribution, probability distribution, Poisson distribution, binomial distribution, sampling distribution, T distribution, and F distribution. So data, when you collect the data from the population, you may see these different kind of distributions. The objective of normal distribution curve, learning about normal distribution curve, is to understand the topic on normal distribution and its importance in different disciplines. At the end of this lecture, the student will be able to draw normal distribution curve and calculate the standard core and all. Okay. What is normal distribution? The normal distribution is a descriptive model that describes real world situation, and it is defined as continuous frequency distribution of infinite range that can take any value, not just integers as in the case of binomial or Poisson distribution. This is the most important probability distribution in statistics, an important tool in analysis of epidemiological data and management science. Yes, okay. The normal distribution curve is often called the Gaussian distribution after Carl Friedrich, who, uh, who discovered many of its properties. Gauss, commonly viewed as one of the greatest mathematicians of all times, and he is honored by Germany on their 10 Dutch mark bill. Okay, this is not important. We will just directly go to the definition. It means mean is located in the center or mode of normal curve. The standard deviation is the distance from the mean to the inflation point of the normal curve. The place where the curve changes from concave down to concave up. Measures of central tendency are median, mode, and mean. The median means the central value of the data set arranged in order. The mode is the value which occur with most frequency in the given dataset, and the mean is the calculated average of all the values in the given dataset. Measures of dispersion and variability. There are several terms that describes the dispersion or variability of the data around the mean, which is range, variance, standard deviation, coefficient of variation, etc. Now coming to the range, the range is the difference of spread between the highest and the lowest observation. So range means it is a difference or spread between the highest and the lowest observation. It is the simplest measure of dispersion. It makes no assumption about the central tendency of the data. Calculation of variances. Variance is the measure of variability about the mean. It is calculated as the average square deviation of the mean. Okay, it is calculated as average square deviation of the mean. The sum of the deviations from the mean square divided by the number of observations corrected for degrees of freedom. Now this is the calculation of variance. S square, that is sum of squares, is equal to summation of x and x minus x bar square divided by n minus 1 mg per dl. The degree of freedom means it represents the number of independent comparisons that can be made among a series of observations. The mean is calculated first, so the variance calculation has lost. Mean is calculated first, so the variance calculation has lost on degree of freedom. Calculation of standard deviation is the standard deviation is the square root of variance. The standard deviation is the square root of average square deviation from the mean. It is commonly used due to the same unit as the mean and the original observations. And standard deviation is the principal calculation used to measure dispersion of results around a mean. Now calculation of standard deviation is this: root summation of xi minus x bar square divided by n minus 1 and is equal to variance. Construction. A normal curve is drawn by first drawing a normal curve. Next, place the mean on the curve. Then place sigma on the curve by placing the segment of the. Anyways, I'll get a better presentation. This is too theoretical. Okay. So theoretical normal curve. I don't know what it is. Theoretical, it's a normal curve. Okay, this is wrong. Right. Yeah, this is a wrong diagram, because there is here okay, here so this is a wrong diagram I am saying it. Here at the tail is not merging with the base. In normal distribution curve, the tail is continuous. It's at the higher level than the base, and it is infinite. Okay, so there's a little error here. Now, characteristics of the normal distribution curve is a normal distribution curve is the bell-shaped curve and symmetric, and it is symmetric. The distribution is determined by the mean, which is symbolized as mean like this, and the standard deviation sigma, which is described that as this. The mean controls the center of the sigma, and sigma controls the spread. Mean controls the center and sigma controls the spread. So in this picture, if this is a mean is a central value, and it's a mean average of the entire value, calculated average, and standard deviation, this is standard deviation, and how far the value is deviated from the central mean is standard deviation. Standard deviation 1. So there is one standard plus and minus one standard deviation, plus and minus two standard deviation, plus and minus three standard deviation. If you see, so for any normal curve with the mean and a standard deviation sigma, 68% of the observations fall within one standard deviation. Sigma of the mean, 95% of the observations fall within two standard deviation. 99.7% of the observations fall within three standard deviations of the mean. Okay, so this area one standard deviation plus minus covers 68% of the data. Two standard deviations covers 95% of the data, and 99.3 standard deviation covers 90.9.7% of the data. It is not 100% because, as I said, this edges don't meet down; they are continuous. Okay. The normal distribution, also known as the normal curve, when plotted, gives a bell-shaped curve with three characteristics. One is the total area under the curve is 1.0. Two, a normal curve is symmetric about the mean. Three, the two tails of the curve extends infinity. See, I told you earlier also, I told you, right now also it is written here, clearly telling you the tails of the normal distribution curve should go infinite. Just check the time. Okay, so I'll stop here. 24. So we'll discuss this tomorrow. Continue this tomorrow.